Alright, let's do some measurement invariance in M+. What I'm going to do here is just a basic invariance test, and then in subsequent videos I'll make partial metric, partial scalar invariance videos. But for this one, we'll just keep it pretty simple. You're familiar with everything up here until probably the analysis line. In the analysis line, I've added something new. Model is configural, metric, and scalar. This tells M+ to produce chi-square difference tests for a configural model, which is constrained between CS and BC, which is our grouping category, and then to constrain the regression weights between those two and the intercepts between those two, and to produce chi-square difference tests for those comparisons. I've also asked for modification indices and standardized output, although the modification indices won't actually show up as long as I'm producing these models. So if I want to see mod indices, I need to comment out this line like this. I'm not going to do that at first though, because I want to see if there is a difference between these models in these model comparisons. So let's run this. Save changes, yes. All right, it looks like it ran successfully. No warnings or errors. What we want to do is go straight to the model fit information. Now for configural invariance, we want the model fit to be good while assessing the configural model. Using just the chi-square assessment, we can see the model fit is not good. The p-value is less than 0.05. But that's a pretty strict and influenced measure. So let's go down and look at things like the SRMR, the RMSEA, the CFI. So here we are, RMSEA should be less than 0.06 ideally, and it is not, but hopefully less than 0.1, which it is, but the confidence interval you can see does bridge 0.1. So the RMSEA is not fabulous. But the CFI, which should be greater than 0.9, ideally greater than 0.95, but greater than 0.9 is probably okay. And the SRMR, which should be less than 0.08, both of these turn out just fine. So we might say we have configural invariance. But do we have metric and scalar invariance? To find out, go back up to the model fit information, invariance testing, and you're going to look at this models compared and just these first two lines here. These are the chi-square difference tests for the metric model versus the configural model. And this tells us if there is metric invariance. If the p-value is greater than 0.05, if that's your threshold, then the models are not different, which means they are invariant. So we do have, according to this p-value, metric invariance. For scalar invariance, we look at this line. P-value is far less than 0.05, so we do not have scalar invariance, which means the intercepts differ substantially between the bill collectors and the customer support reps. Now let's say we did not have good model fit. In fact, we could argue that we don't have good model fit, which means we don't have configural invariance. We would go down to the modification indices, which are not shown here, and we would see where the models differ the most, or where there are parameters that could help if we estimated them. To pursue scalar invariance further, we'd have to do a partial invariance test, which is not supported by M+, but there are ways around it. I will show that in a different video. So for now, let's just pretend that we did not achieve configural invariance. What I would do is I would go back to the syntax, and I would comment out the analysis line so that I can see modification indices. Let's go ahead and save this and run it. And you can see now modification indices are an option. So let's click on those. And you can see that the largest one, this is for the CS group, there's also for the BC group down here. But the largest one is this one, part 1 with part 3. If I look down at this BC group and look for the same one, look, it is also the largest one. So part 1 to part 3 should be correlated, is what it's saying, or at least its errors should be. It's not recommended you covary the errors in a measurement model. So what this also means is these two items are highly redundant. Now, because I know we have a reflective model here, I could just delete part 1 or part 3 to see how that affects model fit. Before I do that, I want to look at the diagram. I like a visual view of things. Now this is the diagram for group CS. I can also look at it for group BC in just a moment. Let's change this to view standardized estimates. Here we go. And let's look at part. Here's part 1, here's part 3. And you can see that part 1 has a slightly lower loading, at least for the CS group. To view the BC group, we would go to View, Change Group, change this to BC, hit OK, and we can see the loading here is also fairly small. So let's see what happens when we remove part 1 from our model. Okay, let's go back to our syntax and try removing part 1. Now when we do this, notice there's an asterisk here, which is the command to remove the automatic constraint from part 1. We'll need to move that to part 2, since part 2 will now become the first item on that factor. There we go. And remove this comment here so we can see the metric invariance test again. Save and run. Okay, model fit information. And you can see the p-value has increased. It used to be 0.2, it's now 0.5. And if we go down to the RMSEA, we can see if it has improved. It has not. Neither has the CFI or the SRMR. So what do? Removing part 1 didn't help. What we could do is go see how part 3 is faring. You may recall from the model that part 1 and part 3 were both fairly low loadings. They probably moved together. So let's do this. Let's go back to the model results and see how part 3 is doing. Here we are, part by part 2, 3, and 4. Here's 3. Ooh, really low loading. So yeah, part 3 is not doing so great. Taking out part 1 wasn't helpful. Now taking out part 3 is also not advisable because then you only have 2 items on a factor. So which is worse, covarying part 1 and 3 to account for their systematic correlation due to being reflective and interchangeable, or removing both parts? I would say in this case it's probably better to just covary those 2 items. So let's try that. We'll go back to our model syntax, bring part 1 back in, and what we'll do is right under this we'll say part 1 with part 3. And that's just going to covary them. Not fabulous practice, but does fix the situation for now. Save that, run it, and it's certainly better than deleting both items. Let's go see how this affected the results. We can see that this p-value has increased. Let's go look at the RMSEA. That value has decreased down to 0.072, which is closer to the 0.06 ideal, and the lower limit does include 0.06, and the upper limit does not include 1. So we're probably okay here. The CFI is now above 0.95, and the SRMR is below 0.08. So we're good. We have configural invariance.